Welcome to my YouTube channel where I simplify the web. In this video, I'll be explaining how recursion works with the call stack in JavaScript. In my previous video, I simplified the concept of recursion and I showed how they were similar to loops, just like for loops and while loops. And I also explained what the base case means in recursive function, which allows you to avoid infinite recursive functions and also avoid the error that says maximum call stack size exceeded. But one thing I didn't explain very well in the video is how the call stack works with recursion. Yes, there is already the error that says maximum call stack size exceeded, but what does that error actually mean? So in this video, I'll be continuing from where I stopped in the previous video by showing you how the call stack works with recursion. Also, if you haven't watched that video yet, I recommend that you check it out. I'm going to leave a link to that in the description of this video so that you can watch it and then you can get the better understanding of this video. Here is the recursion example that I showed in the previous video. We have this print hello here, which calls itself here, which is where the recursion takes place, and then here we increase this counter that we have initialized here, and then here we have our base case for which if the counter is greater than 6 then we return, which means we terminate the recursive function. So if I come here and I run this file, you can see we have hello 1, hello 2, hello 3, and then when the counter is 7, since 7 is greater than 6, then our base case is met and we have the return keyword which stops the recursive function. Well, like I said in this video, I'll be explaining how recursion works with the call stack. So first, what is the call stack? Now the call stack is a way for JavaScript to keep track of the function that is being called and also the functions from that function that is being called. So basically, when a new function is to be called, it is added to the top of the call stack, and after it is completely executed, it is removed from the call stack. I'm going to show you some examples here to explain how the call stack works. Let's say I have a function called print hello, and here this function is just going to log hello to the console, and then down here I call print hello. Let's assume this is the call stack, so I'm just going to have a call stack here like this. Now this call stack is like a stack, of course. You can think of it like a box, and then any function that is called on this call stack will be added to the top. So here the call stack is empty. Let me just have some dash 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 to indicate it's empty. Now when we call print hello will be added to the top of the call stack like this, and after print hello is completely executed, then it will be removed from the call stack. What does it mean for print hello to be completely executed? It can be two things. Number one is all the code in the print hello function has been executed. So let's say we have like 5 lines of code like this. When all of these are executed from here to here, that means the print hello has completed its execution. The other way that the print hello can complete its execution is when there is a return statement. So let's say we have a return statement here, which means when the print hello executes this and executes this, once it comes to this line, then the print hello would stop its execution. So like I said, when the print hello stops its execution, then it's going to be removed from the top of the call stack. Now let's say inside this print hello we also declare another function that says print hi, and inside this function we're just going to say console log hi, and then down here still inside the print hello function we call print hi. If we come here and we run print hello, then print hello would be added to the call stack to the top like this, and then inside of print hello we have print hi, which we execute here, which means on top of the call stack again print hi would be called. Now after print hi has finished its execution, it will be removed from the call stack, and then if there's any other code here, it will still execute, and then after everything has been executed from print hello, then print hello would also leave the call stack, leaving the call stack now empty. So you can see that this way the call stack is able to keep track of what function is being called at any moment. So how does this apply to recursion? Now I'm going to show you. So let's say I clean all of this, and then inside of this print hello I still call print hello, which is of course where the recursion begins. So what this means, let me create some space here. So what this means is that when we call print hello here, print hello would be added to the call stack, and then inside of print hello we log this to the console, and then we call print hello again. So print hello will be added to the call stack again, and then by calling print hello again, it's going to come back here console log hello, and then it's going to call print hello again, and then here we're going to have print hello like this. Since we don't have a base case, we're going to have print hello until the maximum call stack is exceeded, which you can see when I run this file here. So you can see after logging so many many hellos, adding so many print hello to the call stack, then here we have maximum call stack exceeded. So the reason why this error exists is because this call stack has a limit, and because we have so many things in this stack now, then we have this maximum call stack size exceeded, which of course is going to crash your application. And that is why we need a base case. So a base case creates a limit for our recursive function, which means when it gets to a particular point and that base case is met, then we want to terminate the recursion. Now, how does a base case interact with the call stack? So I'm just going to come back here and copy this from here. So I'll come back here and I paste this here. I'll uncomment it, and then I'll also have the let counter equals 0. So how does this work? Now we have our counter, which is 0, and then here we say console log hello. I'm gonna clear the console here. We have console log hello, we have the counter increment, then we console log the counter, we have our base case, and then we have the recursion. Now this is what happens. So I'm going to clear this call stack again. So first, when we call this print hello, then right here print hello is added to the call stack, and inside of this print hello we have console.log hello, which means this is going to log hello, and then we also have counter plus plus, which means counter is now 1, and then we console log counter, which means counter here is 1, and then we have this base case. So is counter greater than 6? Since counter is not greater than 6, this base case is not met. Then we call print hello again, which means print hello is added to the call stack again, and inside of this print hello we call console.log hello. So here again we have hello, and then we have the counter incremented, and we console log the counter, which means the counter here is now 2. This does not meet the base case, so it leaves this line, and then it comes down here to call print hello again. So because of this, we're going to have 3, 4, 5, we're also going to have 6, and then we're also going to have 7. So right here the counter plus plus, and then when we console log the counter we have 7. Is 7 greater than 6? Then yes, our base case has been met. And since our base case has been met, it means that this function that is currently in the call stack is going to be popped out of the call stack. Why? Because the function has completed its execution. There is this return statement that indicates that this function should stop its execution. So what that means is this print hello here is going to leave the call stack. Now for the previous function that was in the call stack, remember it's called print hello at this point. This was where it stopped. It stopped right here at this point, and then it's called print hello. So since this print hello has already finished its execution, this function is going to continue from here. So there is nothing in the next line, and since there's nothing in the next line, it means that this print hello has already finished its own execution, and because it has finished execution, it's going to be popped out of the call stack also. And then same thing, the function that called this previous function that left the call stack also stopped at this point here, and stopping at this point here means it has already finished execution. So this will be popped out of the call stack, this will also be popped out of the call stack, this will be popped out, this will be popped out, and then for this very last one, which is also going to continue its execution from here, there is nothing after this, which means it has finished its execution, and this will be popped out of the call stack. So this is how declaring a base case in a recursive function terminates the recursion. Basically, when the base case is met, then the functions will start popping out of the call stack until the call stack is empty. So if I come here and I run no test, you can see we have hello 1, hello 2, hello 3, hello 4, hello 5, hello 6, hello 7, and once the counter becomes 7 and this base case is met, then the functions that called all of this hello are now popped off the call stack until the call stack is empty, and this helps us to avoid the error maximum call stack size exceeded. So like I said in my previous video, I explained what recursions are, but in this video I'm just showing how recursions apply to the call stack. If you enjoyed it, please give it a like. Also subscribe for more concepts I'll be simplifying in JavaScript.